Hello class. On this particular problem here we have three types of cigarettes. Here's the data here. And we want to find out if they're statistically the same or different. So the first thing we need to do is dump the data into StatCrunch. Here it is right here. Okay, note that this is just the nicotine levels for each of the brands. And then go to Stat ANOVA one way. Select the columns that contain the data and compute. Here's your f-stat and here's your p-value. Notice that the p-value is very small compared to alpha, 0.05. Therefore, we reject the null. There is sufficient evidence to warrant rejection of the claim that the three cigarette categories of cigarettes yield the same mean amount of nicotine. Do the filters appear to make a difference? Well, if you go back and look at the data, okay, VAR1, VAR2, VAR3, okay, it looks like VAR3, okay, which based on my data here is the filtered 100 millimeter non-menthol, okay, is the lowest, gives the lowest mean, and the king size provides the highest mean. Okay, so looking at the responses here, given the king size cigarettes have the largest mean, it appears that the filters do make a difference, although this conclusion is not justified by the results of the analysis of variance. Okay, so in other words, what we're doing here, what we're saying here, is that statistically speaking, there is at least one difference here. But we did not do a post hoc analysis to determine which of the three, I should say, and it may be more, are statistically different. So in order to do that, you'd have to do a post hoc analysis, and essentially you'd rerun the ANOVA, and this time maybe do only VAR1, VAR2, then VAR1, VAR3, then VAR2, VAR3. And if you rerun the analysis, okay, you can see that the difference between VAR1 and VAR2 is statistically significant. So 1 and 2 are different. And then redo it again for VAR2 and VAR3. And you can see that VAR2 and VAR3 are not statistically different, so they're the same. So 1 is the different one. Now, what I will point out to you is that this method of doing post hoc, okay, is not the most robust way of doing it. The best way of doing it is by using Tukey's HSD. And you can also compute homogeneity of variance if you want to, and compute these results here. And you can see here that if I do VAR1 minus VAR2, okay, you can see the results here. VAR2 minus VAR3, so you can see the results here. So you can see that VAR1 minus VAR3, okay, is statistically is the highest difference. And then if I scroll down here, okay, VAR2 minus VAR3, those are the same. So what it means is that the difference between 1 and 2 is not significant. The difference between 1 and 3 is highly significant. The difference between 2 and 3 is not significant at all. Okay? Thank you.